Hello, Algebra 1. Welcome back. We're going to work on Chapter 10.2 today. We're going to keep talking about data, right? This is our new topic for the end of the year. It's data. Yeah, last lesson, we talked about measuring the center of data, right? We talked about finding the mean, which we also call the average. We talked about finding the median and the mode, and then how to find percentiles. And those are ways to measure the center of your data. Like, where is the middle of your scores on a test? Like, what is the middle that everyone's got? Or what's the average height everyone has? What's the average age? Those are measures of center. Later, we'll talk about a different kind of measure. But today, we're going to talk about representing data. And we're going to get started because it is hot today, and I don't want to record forever. All right. So we're going to talk about representing data. How can we draw pictures of our math? How can we make a picture of the math we're going to do that will help us understand what we're learning, right? It's nice if I know the average height is 5'8". I don't know. But how many people are 6 foot? How many people are 5'4"? If I just know the average, it doesn't give me the whole picture. So today we're going to try to look at the whole picture of data to see what we're going to learn. So we're going to start with an idea called a dot plot. Okay? You probably have seen something like this. And it's pretty easy. And it has what it does is it measures the frequency. How often does a score or a height or one data point, one value show up? So it shows us the frequency of data, right? So this is a short list over here. We can count there are how many 40s we got. But if we have a huge list, it's hard to judge what numbers we have more of. So drawing a picture, you'll see, will help us see it. And it doesn't just help us with that, with frequency. It also helps us see. So we could see the clusters and the gaps. So in science, maybe in medicine, this could help us. So we see this clusters and the gaps. So in medicine, maybe this helps us. We do an experiment and we're trying to figure out if this new medicine will work. And we see the average. That doesn't help us very much. Oh, the wind is loud. Hold on. Okay. The average might help us, but we have a lot of results. This person healed in 20 days. This person healed in 26 days. And we have thousands of people. We want to see, do a lot of people heal at the same time? Is it spread out? How does this medicine really work? And a dot plot might help us understand that. So a dot plot's very nice when you have multiple of the same numbers, right? We got lots of 40s over there. We've got some 50s. So this will show us where they are and what it all looks like. So a dot plot, the first step is put them in order. Okay, this is a pretty constant. We almost always do this. So I'm going to put all my numbers in order. I've got 40, got another 40, got another 40. How many 40s? 1, 2, 3, 4. Got one more 40. Okay. Then next I have a 42 and then a 43. One of each. 42, 43. Next in line I have 45, 45, 45. Okay. Go to new line, 45, 45, 45. And then I have a 46. Yep. 46. And then I have two 50s. 1, 2. Yeah. 50 and a 50. So maybe this is test scores and it was out of 50 questions. Okay, so some people scored 40 points, some people scored 50 points, and in the middle. All right, let's see. Did I get it right? There's 12 numbers and I have 6, 12 numbers over here. Good. Okay, put them in order. Then number 2 is a number line. Somebody's cranking something loud outside. Okay. So on the number line, we're going to draw our line first. Okay. And it's easy. We start with our lowest number, which is 40. So the first mark we make, the first tick mark, is going to be at 40. And the last tick mark is going to be at 50. I hope I have enough space. And this, I see, there's a lot of numbers in between. So maybe I'll do counting by 1. So 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Boom. So 41, 42, 43, 44. So this is when you might need to, if you have different numbers, you might need a different scale, right? If I had a really big spread, like if I started at 40 and went up to 500, I might need to count by 10s or 20s to fit all of the numbers in here. And that's okay. Then you could, anything that was from 0 to 20, you put in one line, and so on. Okay, I'm going to use a different color just to make it look nice. Get the purple. So now that we have our number line, we're going to put dots for each of our data values. So for 40, I have 1, 2, 3, 4 of them. So at the 40, I'll put 1, 2, 3, 4 dots. 41, no dots. 42, there's 1. 43, 1 dot. 44, no. 45, I have 3 of them, okay. 1, 2, 3. All right. 46, I have 1 dot. And 50, I have 2 dots. Okay. So there's the picture of our data. That is a dot plot of our data. I'm going to zoom in a little bit. We'll talk about it for a second. So this helped us see that a lot of people got 40. There's a cluster here, right? There's a big group here. There's a big group in the middle. And there's 2 people at the top. So nobody scored 41, 44, 47, 48, 49. So there's a gap here where nobody got these questions right. But a lot of people could get 45 questions right. A lot of people could get 40 questions right. And a couple people got perfect. So this would help us think, man, is this a good spread for my test? Maybe this is what I was looking for, right? It looks pretty good. 40 out of 50, that's still an 80%. So maybe this is the strong scores. But this lets us look at all the data. These are the test scores in a picture form. That is how we represented the data. Representing the data means looking at the math picture, right? So that's a dot plot. Those are good when you have, scores like this where you can easily put them on a dot plot. And it helps us see the frequency, like how many people got 40, how many people got 45. And it sees the clusters and the gaps, right? Where did the most people have scores? Oh, most people, right? If we look over here, the top of the scores is pretty empty and the bottom of the scores has everybody in it. So most people didn't do a perfect job on this test. Something to think about when you make the next test, right? So this lets us learn about our data. So that's a dot plot. Now we're going to talk about a bar graph. Now these, I'm guessing you've talked about before. These are pretty common, right? And this is something that we use when we want to, I guess we're using red on this board. Where's my red marker? When you want to compare categories. Let's see, needs to fix. So we're comparing categories. So we want to know, do more people like chicken, pizza, salad, wraps, burritos? I don't know. We want to know what kind of food people like, and it would be different categories of food. More people eat breakfast. What's your favorite meal? Breakfast, lunch, dinner, midnight snack. And we would count them up, ask everybody, count it up, and we would have different categories that we could compare to find out who likes what. So this is for comparing categories, not when we just have a list of numbers. We want to have nice categories we can put it in. So we're going to go through the steps for this one. So let's see. For example, we would say, okay, like we'll do my dinner and lunch and breakfast. So who likes breakfast? Who likes lunch? Who likes dinner? And who likes snacks? Okay, so we would take our categories, and we'd probably ask a bunch of people for this one, right? There's different ways to get the data, but I'm going to say, we get that. Oops. Okay, that's what we get. I don't know. I just made it up. But that's our counts. So this is our data. We have 4 categories and 4 numbers. We have 6 people who like breakfast, 3 people who like lunch, and 12 people who like dinner, and 7 people who like snacks. Okay, so the first step is draw your axes. Not axes, axes. And label. So, I'm going to draw my y-axis and my x-axis. Ooh, I ran into the couch. Let's fix that one over here. Okay. So, the categories go on the bottom. So, your favorite meal, right? Fave meal. And the question, the answers were, breakfast is B, lunch is L, D is dinner, S is snack. Okay? Breakfast, lunch, dinner, snack. What's your favorite meal? On the side, we would write number of people, right? So this also shows us the frequency. So I'm going to say that I can go from 1 to 12. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Give us a little extra space just in case. Okay. Now, a lot of the time, we can make it fancy. So I'm going to say breakfast is orange, sunrise, And breakfast goes up to 6. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we make a bar and we color it in. So that's breakfast. That's how many people like breakfast. You can do it all in the same color, but I'm going to make mine different colors. Then we got lunch. Lunch counted up to 3. So I make the top of my bar at 3 here. And then there we go. Dinner. Dinner will be blue. Dinner had 12. Okay. So we go up to 12. And it's like right here. Yeah. Color it in. You don't have to color it in. I'm just making mine look nice-ish. Okay. Dinner is blue. And snacks will be pink. For fruit snacks, I don't know. Snacks, 7 people liked snacks. So it's a little taller than the breakfast one. Okay. There's my bar graph. It shows the different categories, breakfast, lunch, dinner, snacks, and we can compare who likes which category better, right? Oh, look, breakfast and snacks, almost the same number of people, but a lot of people like dinner and only a few people like lunch. Okay, remember I made this up, so this isn't real data, but it's a real graph. Draw your axes, label, and then make your bars. Somebody's playing music outside. Okay, so that's a bar graph. It's a good way a lot of times to show people information quickly, right? In a company, maybe they would ask you to make a bar graph if you're building toys, and they say, what ages liked these toys? What kind of people? Did boys like these toys? Did girls like these toys? Did little kids like it? Did teenagers like it? Who liked this stuff? And you could make a graph to compare those categories. Bring it to your meeting. So it's good to know. Okay, last one for today is the histogram. So a histogram is a way to talk about the frequency of numerical data in equal intervals. So number data, that's what numerical means. We'll say it's number data, not like the last one. Remember, the last one was category data. This is number data in even groups or intervals. We'll say intervals, but that means a group. So it's number data in equal groups. So you'd have a lot of different numbers, but you could say, I'm going to count all the numbers that are from 0 to 1, or 0 to 10, then 11 to 20, etc., etc., etc. So you would make chunks and see which chunk had the most data in it, right? You could do this with test scores. This is a good one for test scores again, right? You could say my groupings are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So how many people got an A, which is 90 to 100? How many people got a B, which is 80 to 90, right? So you can check your score, and it should look like a nice curve. Okay, this is not for categories, right? If you wanted to make a graph of categories, then you can make a bar graph. They look similar. They look almost the same, but there's some differences. Okay, so this is a histogram. For example, here's my data. So write this down for your notes, but now I'm going to do my data. This is the example from your book, not from the assignment. And I got a chart, and it says it is the age and the number of people at that age, and this is presidents. So U.S. presidents, and this is when there were 44 presidents. So the total is going to be 44, or it should be. U.S. presidents. Age. So what age did they get elected? Were they between 40 and 44? Were they between 45 and 49? Were they between 50 and 54? Were they 55 to 59? '60 to 64? And 65 to 69. So this is up through Barack Obama. All right, and then I need to check because this got cut off my notes. Okay, it goes 2, 7, 13, 12, 7, 3. 2, 7, 13. No, that's 13, sorry. 13. Oh, I did it backwards. But this is 7, 3. Let me write that down real quick. Okay, this is supposed to be 12. This is 13. This is 12. Okay, there we go. So this is the U.S. presidents. So we're going to make a histogram to show the U.S. presidents. So here's my histogram. Histogram. Okay, it starts out looking the same as the bar graph. We make our axes, okay? On the bottom, though, we put our ranges. So what are the age ranges? One of them is 40 to 44. So this, we make a chunk here and it says 40 to 44. Then the next group is 45 to 50, or 49, 59, 59, I think. Next group is 50 to 54. Next one's 55 to 59. The next one is 60 to 64. And this is getting really small, but so on your paper you can make a bigger line when you do a problem like this. 65 to 69. Okay. So there's my categories. Then on the side, we again put our scale. And it goes from 2 to 13. So I think 1 through 15 can work again. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. All right. Now we start making bars. The difference on this one, so in the bar graph, the bars were each their own tower, right? In a histogram, the towers are all connected. So you'll see 40 to 44, it goes up to 2. Yeah? Okay. Then 45 to 50, or 45 to 49, goes up to 7. 1, 2, 3, 4, 5, 6, 7. So do you see now that my bars are touching each other this time because they fill in the whole space? They fill in this interval, this group right here. Right? Our group is 45 to 50, 45 to 49, and our bar fills the whole thing. On a bar graph, it's a category, so it stands by itself. Okay, 50 to 54, this one goes up to 13, so this was 7, 8, 9, 10, 11, 12, 13. And then we fill it in. You don't need to, but I think it looks a little better. maybe. Okay. Then 12 for the next one. So right underneath this. Okay. I'm getting tired of coloring it in. Maybe you shouldn't color it in. Okay. 60 to 64, that's 7 again. So same height as this one. Scribble, 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 scribble. Okay. And then 3. 1, 2, 3. So this way you can see, look at that nice little mountain right there, right? It's called a curve. Nice little curve that we could draw around it. So a few people were 40 to 44, and then more people were older. The most people were 50 to 54 and 55 to 59. Then it goes back down as you get older. So a lot of people that became president were this age, these two ages, right? That's a histogram. Now we're going to talk real quick about a cumulative histogram. Let me get my eraser real quick. Okay, so this is going to be a cumulative histogram. Cumulative. I'll write it bigger over there. I'm really getting tiny words in here. So this is a cumulative histogram. I almost said Instagram again. So cumulative means it adds up. So instead of putting them in their own age groups here, different age groups, we're going to add the age groups each time we go together. Okay? So make my same steps at the beginning. Make my axes. Okay? On the bottom, we'll have the same groups. Right? 1, 2, 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So this is the group that starts at 40. This is the group that starts at 45. This is the group that starts at 50. This is the group that starts at 55. This is the group that starts at 60. This is the group that starts at 65. Okay. To find our numbers for this, we don't just do the same thing as here. We make a new line on our data, and we do cumulative. We started our first number, 2. That one's easy. 2. Now we go to the next one, but we need to add 2 with the next data value. 2 plus 7 is 9. Now we need to do 9 plus the next one, 13. So 9 plus 13, that's 22. Now you see the pattern? So we take 22 plus 12, that's 34. Then we do 34 plus 7. Well, that's 41. 41 plus 3, and that's 44. And remember, this was before Trump, so this is the Barack Obama number, which is 44 presidents. Okay, so we added up to the correct number. There should be 44 total in our chart. And now we can graph these numbers. The purple line that I drew in purple this time is the cumulative values, and those go on the cumulative histogram. Okay, so you have your bottom axis, and we put the categories in there, right? This is the 40 to 44, 45 to 50, 45 to 49, 50 to 54, 55, 56, 55, 59, right? The same categories from this data and from this chart, this histogram on the left. Then on the left axis, we just need to put our scale. And we need to count from 2 all the way up to 44. So go a little bit above and below. So it's going to be 0 to start, and I need to get all the way up to maybe 45. So to fit that in here, I don't want to write 45 tick marks, but I'm going to do a scale. Let's do count by 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So 5, 10, 15, 25, all the way up to 50, okay? You should label them all, but I don't want to do that, but I will. 30 and 20. Okay. Then we start with our cumulative data. 2 is the first one. Well, 2 is way down here, so I'll make a nice small bar. I guess I'm filling it in again. Okay. Next one is 9. Okay, so 9's right here under the 10. Just barely under the 10. Okay, fill it in. What's my next one? Remember, I'm looking at the cumulative line, so each bar is going to get bigger. 22. Well, 20 is right here, so a little bit up, maybe there. Okay. Now, when you draw these by hand, they're not going to be perfect, but there are a lot of computer programs that do this, right? Excel will make you a histogram. Microsoft Word, I think, still makes you a histogram. They might only call it a bar graph, but... And those ones look real nice when they're finished. Okay, next we have 34. So up here, right underneath 35. I'm spending a lot of time coloring in these bars. It's a little easier on paper since it's going to be smaller. This is actually pretty big in VR. Okay, next one is 41 and then 44. I'm going to do these together. 41 is up here. And 44 is up here. Oh boy, it's a lot of coloring. Anyway, I guess there is a paintbrush thing I could use here, but too late. All right, make the tops look nice, and then we'll step back and take a look at our data. Okay, there we go. So on the left is our histogram, where it just shows how many are in each category. And on the right is our cumulative histogram, which counts up how many get added to each category. Okay, so those are the three ways we're going to represent data today. We have a dot plot, a bar graph, and a histogram, and a cumulative histogram. So dot plot's nice if you want a quick way to look at frequency, clusters, and gaps, right? Lots of people scored this number. Lots of people are this height. That's good for a dot plot. They're pretty quick, but they don't give you a ton of information. Bar graphs are good for categories, right? If you have what's your favorite sport, what's your favorite food, and you can group it into different categories, that's good for a bar graph. Then a histogram is when you have lots of numbers and you need to group them into ranges of numbers, right? This was 44 to 49, 50 to 54, the A range, the B range. So there's different ranges of numbers. A normal histogram's nice for seeing where people lie or where the data is, right? Most of the data is in the middle here in this picture. And a cumulative shows you how it adds up, right? So a few people here, a little jump, a big jump, a big jump, A little jump, a little jump. So it gives you the same information as this one, but in a different picture. And they actually, when you talk about Algebra 2, these are different curves that you might see. Right? This is probably going to be modeled by a quadratic, and that one might be modeled by a root function. I don't know. Depends. But these are good ways to look at the data and think, wow, that's what it means when they say most presidents are 50 to 60 years old. Here they are, all of them in that part of the graph. Yes, there's some older. Yes, there's some younger. But most of them are here, and you can see it this time. All right, that's it for today.